What's up, everybody? Welcome to the live stream event for the brand new ROCK R3 Pro V2. So today, I'm going to share with you all about the V2 upgrades, what it means. I'm going to go over some data sets, and really I want to hear from you and answer any questions that you have about the V2 and see if we can get a nice conversation going, because this is the first of many live stream events that we're going to be doing. We really want to communicate with you and get feedback and build a community around LiDAR, drones, SLAM mapping, mobile mapping, and all things really 3D. So here we are today talking about the brand new ROCK R3 Pro V2 that I have here in my hands. So why don't we go ahead and jump into it and start talking about that, because it's really exciting. I just released a video yesterday covering all the new advances with the V2, and a huge shout out to the ROCK engineers and the ROCK team, because they did a ton of work to make this same hardware from the V1 to the V2, but upgrading all the internal components and algorithms, calibrations, literally everything inside of this device right here got a huge upgrade. And we upgraded the ROCK Cloud to offer brand new functionality, which I'm going to cover in this video or in this live stream with you guys, because the new functionality really goes into a whole new ethos that we really believe in here at ROCK. And that's, how do we take all that awesome data that you're getting and make it all usable? Not just some of it, all of it. You know, we really believe that when you buy one of these products from us, it has so much power inside of here. You know, the IMU is amazing. The GNSS is top notch. The computer is awesome. The laser scanner is great. The camera is great. Why would you say it's only good in one platform like a drone? Why not have it be really good for mobile mapping? Why not have it be really good for terrestrial scanning? Why not walk inside of a building and make a 3D model that's super accurate, very high fidelity, and you can make measurements, get all of your accurate CAD models from it? So that's what we're really doing with this product. And the V2 is that first big step towards that direction. So let's jump into it. I'm going to go ahead and actually just share my screen and start talking about the V2 data, what it means for you, or I'll talk a little bit about upgrades. And really, I just want to answer questions that you guys have. So please, if you're watching this anywhere, leave comments and questions. I believe we can get them from all platforms, whoever is. Yep. So we got Facebook here, YouTube, and I believe also LinkedIn is able to leave comments here. Hey, John Miller, did I win a giveaway? Well, maybe, I don't know. You can have give me your address, I'll ship you a soda can. No, don't do that. Anyways, let's share my screen, jump into the data set, and look at what the V2 really has to offer for the accuracy. And probably just do a primer before we do that on LiDAR data, what it is, why it is. So let me open up this data set right here, and we can go ahead and turn off that background music, and we can just start talking about data. All right, guys, so right here, this is the new V2 data set. This is what I flew the other day, and a couple of things that we're starting to do in this whole notion I was just mentioning about the integrated experience, right? So on this device, we have a high resolution camera, 26 megapixel, and these photos actually are used to colorize the point cloud. And then we also have released ROCK Photogrammetry right here. We're going to cover that here in a minute. But also, we have all these photos to do what we're calling ROCK Inspect. And this is a new functionality that we're integrating the photos, the orthomosaic, and the LiDAR data, all to do analysis from each individual component. So right now, this is version 1, where you have the photos and you have the colorization, and it's all integrated in the ROCK Cloud. So essentially, you fly the R3 Pro V2, you process it on ROCK Desktop, and all of this is generated for you and uploaded into this one platform that stitches all data sources together as one canonical source. So that's really cool. So let's just check this out really quick. So I can expand the side menu here and just look at the raw photos. And currently, we don't have editing ability on these raw photos, but we will, where you can make edits on the photos, and that's going to show up on your LiDAR data. But we actually already do have that ability to make edits on the LiDAR data. So you can see right here, this is actually a measurement I drew on this on the live data. So I drew this measurement. It's a polygon. And then I click save over here, and then boom, that actually shows up directly. Oh, I got to refresh the page. Let me do that. This is my demo data set. So I'm going to move that. Boom, click save that. I believe, there you go. That brings it right over to orthomosaic. So you can see that exact same feature translates from the 3D data to the 2D data. And that's just a feature of this integrated vision of having all the data sources tied together. So when you go out and fly or walk or drive, having the ability to have it all synchronized together for one analysis is really, that's the future. And that's why you're going with ROCK. You're going with ROCK because A, it's kick-ass hardware and it gets really accurate data. But B, because the analysis that you can do with this technology, that we're putting in the energy to syncing all that data sources together to give you that canonical source, everything's connected together, view of the data. That's really the power. Like, how do you unlock the power that's inside your data already? And that's like what we're really focusing on. Okay, so that being said, that's a really cool feature. Much more to come on that. And if there is any questions on this, I can go through and click through stuff later and we can do some, just see if we can break it, together on this live stream. But it just went live yesterday, so hopefully we don't. But I think we could if we tried hard enough. Let's talk about the V2 upgrade. So one of the things that we did in this is we really upgraded the IMU and the computer. So a lot of work went into how the IMU. Yeah. So basically, I don't know if you guys know this, but IMUs, these MEMS-based IMUs, they're inherently very noisy devices. And actually, if you open up IMUs from many of the top name manufacturers, you'll find they actually use the exact same components on the inside. So really, what's the difference? Well, the difference lies in the filtering and the Kalman filters that run on the IMU. So how do you take noisy data and get accurate data? That's the question you have to answer to get good, reliable data. And that's what we really worked on to improve your V1 to the V2. So you can see that. So it's all probably just technical jargon when I talk about it. But what does it mean whenever we actually look at it? So I can come over here to GPS time. And so you can see I actually flew kind of this lawnmower pattern down and back, down and back. And usually in the high dynamics portion of the trajectory, so the corners, you're making some high dynamics, or there's a gust of wind, maybe you're flying in, 20, 30 mile per hour gusty winds on the coastline. You want to be able to reliably get the data. Sidetrack for a second, guys. I want to do a quick sidetrack because this is a really important thing. If you think about what is one of these LiDAR sensors. So Patrick, can you bring me back full screen? I want to do just a little catch up for everyone who's watching this. So maybe you're new to this. I'm jumping into the deep end. I want to take a step back for just a minute, and then we'll jump back into it. And we're going to get back into that high dynamics section of the trajectory and looking at that data. Okay, so what am I holding in my hand? This is the ROCK R3 Pro V2, but what is it really? It is a very high-end GNSS system. So actually, the GNSS chip inside of here, it's this UM980, and it's this triple band. I think it's 1,408 channels. I think the cold start. So it's really good. Essentially, if you compare the actual GNSS chip inside of this to something like a Trimble R12, like one of their later, GPS units, that's the quality of GNSS that's actually inside of here. So this is a high-end GNSS. Okay, but that's not all it is. It's also a 5mm precision laser scanner. Okay, so if I put this on a tripod, it's a terrestrial scanner. And a pretty decent one, actually. Pretty good terrestrial scanner. Okay, well, it's that. But now when we're on the drone, we also need to know the exact orientation of this device really accurately. And that's this IMU that we're talking about. And so knowing this orientation, it's an auto level. So if you're looking at getting, a level, on your job site, well, we have to be an expert at doing that, calculating level. So it's an auto level in here. You know what else it is? These lasers that are coming out, we need to know the angles, the turn, turning an angle very accurately. If we don't know exactly, because this has 32 lasers in it, and those lasers are on a fan like this inside of it, and it's spinning around. So it spins around inside this device, shooting out. And every angle needs to be known very, very accurately. What does angles and distances? A total station. So it's basically, we had to be good at a total station. So if you think about, so the whole premise of this discussion today is having all of these devices really unlocked in one, right? So we got high-end GNSS, we got a total station, we got an auto level, and we have a terrestrial scanner. Total station, GNSS, level, terrestrial scanner. And we're going to throw that all on a drone that's flying up in the air with wind, and it's moving all over the place. The drone's vibrating, it's moving like this. So we have to do all of those things while we're in a very unstable platform. Think about that. Just think about that for a second. Think about the implications of having to do all those things, but doing it all while moving and up in the air. So I think that underpins the technology of what these devices are. Not just ROCK, that's what all of them, everyone has to master that to make this kind of equipment. And I think that's pretty profound, and that's really where we're reaching. Not only the data from all these systems, but how do we integrate all of that, as well as all of these features of high-end GNSSs, RTK, PPK, total stations, terrestrial scanners. How do we get the best of all worlds with one package? Okay, that's side note over, guys. Thank you for humoring me for a second to learn that. Let's go back into the implications of what it means whenever those things get better. So one of the items I was talking about is the enhanced accuracy and how these IMUs work, and the filters that run to make the data really good. And that is part of the major upgrade of the V2. And if we look here on the corner section, what we're seeing here is LiDAR points from, I'll zoom out, from this corner and that corner blending together. So high dynamics. And what we're seeing is a very good alignment of those data sets. So that means even under high dynamics, like fast movements, the data will still be accurate. On the V1, we asked customers to cut those corners out. So the data would be totally fine all through your straight stretches. But on those corners, the high dynamics, we actually got less. So we asked people, just cut that out. But we don't want to cut corners anymore. So no more cutting corners of the V2. So that's a major win for the V2 right there. All right. Now let's look into, we come to intensity gradient. So what is intensity gradient? So every time these lasers go out, Patrick can come back to me for a second. This is so you guys all understand what this really means. This is shooting lasers out, 32 lasers. Boom, 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 boom. It's like a flashlight, casting a quick little flashlight beam coming out of this. Now we want to measure the distance, so the time it takes for the laser to go, hit something, and come back. And that time, it's twice the length of the distance because it went there and came back. And so divide that in half, speed of light, we can find a distance. But we also can measure how bright the light is coming back. So if this laser hit a perfectly reflecting surface, a mirror, it would be very bright coming back. Same distance, but lots of light comes back. Same distance, lots of light. So that's what the intensity is. The intensity is looking at it gives you specificity on what objects are. So material properties, different materials reflect brighter, different materials can reflect less. So you can imagine like, on a bright day, going outside in a white sand beach, your eyes get really squinty. That's because it's white and it's reflecting all that light up into your eyes. Very bright. So the sun reflects off that, hits your eyes. Alternatively, you can look at, a very dark, forest, or man, that's not a good example. It's just light not getting in there. Blacktop, something like that. Your eyes are going to be much less, a lot less photons hitting them. Even though light's hitting it and bouncing your eyes, it just reflects less. So it's going to absorb. So light has to go somewhere. It doesn't just disappear. So it's going to reflect, refract, or it's just going to absorb inside that material. So it would absorb. So go back to the screen. That's what we're looking at. This is the amount of light reflecting back. We call that intensity. So if I flew closer, it would give me more light coming back because it was more concentrated on that object. If I fly farther away, that light's going to spread out as it flies away, and potentially less comes back to be recorded. But let's look at, in this intensity view, a couple objects here. So on the V2, this is from 100. So I flew 150 feet on this data set. So it's 150 feet, and I flew about 5 meters per second. And we can look at things like curbs. I come down to this curb and just see what it looks like, raw data. So what do I mean by raw data? I just mean the raw measurements from the IMU, GNSS, and the laser being projected onto the Earth or the real world. So we also have a lot of optimizing algorithms that run because we do the SLAM development. So SLAM relies on only computer vision, and we can talk about that later. But suffice it to say that in SLAM, that computer vision is what we're doing to say these points equal these points equals these points in order to stitch together a 3D model. We can use those same types of algorithms to enhance the accuracy of the noise. So statistical methods to look at, statistical methods to look, can I move this higher on my screen so you guys can all see this? To look at the up, down, you see how there's just little bits here, uncertainties. So you can apply statistical methods to actually minimize that. So law of large numbers, you take enough measurements of a population, you can find the mean. That's all it really does. But this is without doing any of that. This is just the raw measurements. And so you can see what a curve would look like from 150 feet in the air. So that's really important when you're doing planimetrics with this kind of system. And to get top of curb and to get this gutter line, it makes it very easy, very straightforward. And that's something else that we actually offer through ROCK Pro services. So one of the things about ROCK is we take you from A all the way to Z. So the V2, you can go out and capture data. You don't have to use our pro services, but we offer a very good service that you can use to get from A to Z. So if you just want to go out and fly the data and have our pro services team engage and get the line work and pull all those CAD features out from your files, from your data, that's our pro services. We have a whole team that does it. It's an awesome service. But that's not what we're talking about today. We're talking about the V2 still. And so this is looking at some of the calibration that's being done on the Hesai as well. So this is the Hesai XT32 laser scanner on here. And we have to recalibrate it from the Hesai itself. So we have a new technique that our ROCK engineers have been working really hard on. And it's been awesome to work with them and see how not only have we been able to increase the accuracy of the Hesai, but we've been able to use computer vision and a lot of these techniques to make it very robust and very accurate. So that's the other thing. So I talked about the IMU. Now we're looking at these very fine, sharp features. And sharp features are something that you don't get. So if you were to look at like the DJI L2, you would see you can get very good vertical accuracy, but it'll smooth over everything. So all the curves disappear, all objects. If we look at like fine detail, like right angles, like this is a duct here, those right angles there would disappear. But because the raw data is very accurate, we are able to still preserve the fidelity of those angles and et cetera, et cetera. Hope you guys can kind of understand. Ask me questions about that later if you didn't understand it. Maybe I explained it well. Now let's talk about the colorization. I'm going to come over here and share. Actually, I saw this the other day. I thought this was really cool. So I flew this a week ago, something like that, 2 weeks ago. But this is a light pole. And this is just something you don't usually see in LiDAR data. So I find it particularly cool. The actual lamp of the light pole here is colorized, as gray as it is. And the actual, all the points that made it on the pole are the color of this pole in real life. And you don't see any of those points on the ground. So just, I don't know. To me, this is peak performance. That's what I'm just like, have I seen this other places? I really haven't. So yeah, it's really really cool. I'm just happy with the development team and what they've been able to accomplish. Just looking at the alignment of the curbs and even like, so this is point cloud data. I could see a crack in the point cloud data, right? Now, obviously I can flip over, not obviously, but now with the V2, I can flip over and find that same spot. Where were we? I think this is the lamppost. And I can zoom in on the orthomosaic. And so now I can actually visually see it. I can do measurements on this, and I can also do the 3D measurements over here on this data set as well. So I can actually increase the point size a little bit, kind of see the crack a little bit better. Yeah, it's pretty crazy. I like 2024. It's a good year. Detour, I see a question from someone. Logan, has there been any progress in colorized SLAM data? Yes. Next week, live stream, same time, same place. Wednesday's a video. Hopefully we get it all done and ready. We're actually going to go colorized SLAM data set directly following the live stream today. And then we're going to be announcing and launching that next week. But I didn't tell you that just now. So I'm glad we did it in private. I'm glad no one else heard this. And it was just between you and me and no one else watching. But yeah, next week we're doing that. And so that's going to be the handheld. You can see it here in the background if you look closely. And so that's coming out. And then we have mobile mapping, our new mobile mount coming out. And with the mobile mount, we have colorized. So this whole ROCK Inspect, this view. So this also works with the SLAM mount. We're going to cover more on this, but sneak peek, SLAM mount with ROCK Inspect, photospheres, being able to do like Google Street View walkthroughs, as well as colorize the point cloud. And then also same thing for mobile data. So mobile data, having the photospheres, be able to kind of Google Street View through it, as well as have the colorized point cloud. Really exciting. I mean, it's really, really, really good. But back to the V2 upgrade for everyone. So that is a little bit about the colorization. And I mean, there's something else I found just particularly impressive. Where was this? Oh yeah, it was this curb here. I don't know. Just let me turn the point size down. Just seeing this curb colorized was really impressive to me, because it's just a small object, and there's probably like 6 photos on that one curb to see how well the alignment happens. Now, there is one caveat to all this, everyone. So you still have to, if you take the camera off, you want to full screen me for a second? So, with all great power comes great responsibility. Okay. Now, if you take the camera off to put this on the SLAM dock, because it goes right there, you have to redo this alignment. ROCK Desktop, if you have just a couple features, especially with the V2, I think this took all of like 2 minutes, I believe Alex spent to calibrate this. You just say this point equals this point equals this point. You do like 4 of those, and you click save, and it recalibrates it. So it gets in pretty close. It's really close, but then you just add a couple. If you don't take it off, though, and you just leave it on in this mode, so you're just always going to be flying it, you don't really have to do it that often. Rarely. If you just, unless you bump it, it's got screws right here. So those screws come off. You can take the camera off, put it back on, and then you'd have to redo the extrinsic calibration, what's called, the orientation as to this. So anyways, back to the data. All right, guys. So we covered the high dynamics, the increased accuracy, the better colorization. We talked about the enhanced calibration on the lasers, the Hesai itself, and shown some curves, shown some features. I'm going to go out and get several more data sets to kind of keep showing off the V2 upgrade. Now, for anyone who is interested in the V2, interested in doing, an upgrade, we're going to be offering that. It's about $2,000 to upgrade it. We have to get your unit, physically upgrade the individual components, and then we're going to fly it, we're going to test it, we're going to do a full calibration of everything, and then send it back to you. I do want to offer a discount, though, because we make this content. Obviously, we're very YouTube first. You can bring me back full screen. We're very YouTube first here, very, community oriented at ROCK. We really believe in hearing your stories and us sharing stories with you. So we're going to offer, if you create a quick 30-second video talking about who you are, what you do, and what kind of success you've had with this hardware and ROCK, and share it with the community, then we're going to offer you a big discount on that. So email us, support@rockrobotic.com, and then we'll get you on the wait list. And then we already have a bunch of people that reached out. So sooner you do it, you're going to get first come, first serve. And then on the other side, all new units are just now V2. So V1 has stopped shipping. It's the same hardware. We're just upgrading all the firmware and the calibrations to give you that accurate data from edge to edge all across your data set, anytime, anywhere, right? So that is that. Okay, let's jump into more of the data sets. I want to share something about the ROCK Photogrammetry. So launching this week with V2 is ROCK Photogrammetry. And ROCK Photogrammetry comes with the V2 in your ROCK desktop. Anyone's going to be able to get this. We're just going to include it for 6 months. It's a very good beta. It works, and we're just going to keep improving over it in the next couple months. But now you can fly one time and then get your 3D point cloud, get your orthomosaic, get your inspection photos, have it all tied together, and ROCK Desktop will generate all this for you. And then you just, at the end of ROCK Desktop, you click upload, it syncs it to the cloud, and now you have this platform that's going to help you analyze all that data. So that's kind of how it all works together. Let's talk about ROCK Photogrammetry because it's totally different in how we imagined to do this over how Pix4D and Drone Deploy or others do this. Let me turn this off and turn this off. Actually, so I got this background here. I'm going to change this from aerial to road so you guys can see. So a couple of decisions we made in the development of ROCK Photogrammetry. One, we wanted to prioritize accuracy over beauty. It is beautiful, don't get me wrong, but accuracy was the #1 priority. And what do I mean by that? So let me share, before I jump into this and start zooming around, I have a project that I did over here. This is in Drone Deploy. And this was a Mavic 3 Enterprise. And I believe I flew it at, I think it was like 90% and 80%. I think I did 90 forward, 80 side. So a lot of overlap, and I flew very low. I think I was only at like, so these trees right here were like, I think they were like 60 feet. So I must have been at like 90 feet, something like that. So very low. Okay. I want to point out a couple of things that we notice in photogrammetry that we wanted to address and try making better. So with this, we have this corner of this building. Okay. Now we can clearly see the facade of the building here. Now, you tell me, where is the corner of this building? So if you need to do some CAD work on this, you got to draw the corner of this building. Where's the corner? Can't really find it. Okay. I think the point is you don't know. You could say here, but you can also look down here. You can see the bottom of the ground there, and you see that. You can draw a straight line over here. So you could say over there. And I drew a little line here from those two estimates. And that's about a 4-foot difference, right? So inevitably what you would do is you would go, well, I don't know where the corner's at. So you'd send someone back out in the field, and they would either use a total station or a GNSS, and they would go get a shot there at that corner. So that's what you would do. And then you would come back to your office and say, well, I'm never trusting building corners ever again on my orthomosaic. So that's what we wanted to address with one of the things we wanted to address with ROCK Photogrammetry. So if you actually notice, if you zoom in, you'll notice that the corners, there's like a little, you can see cuts happening here in the data set. And that's because this is the actual location of that corner of the building. That's where that's located. If I come over to other objects, let's come to that lamppost again. Where was that at? Here's that lamppost. This lamppost, now you can see the cuts here. That's because this lamppost, where it's showing here, that's where it is in X and Y in the real world. So that location is where the location of the lamppost is at. This location is where the lamp of this lamppost is at. And so that's what we're doing. We're prioritizing the accuracy of objects over the beauty. So you can see there's cuts because there was no photo in the spot actually, because the lamppost was blocking that spot and blocking that spot. And so there was no information, but we forced it to be there. And that's what happens in rock photogrammetry. We force the geometric correctness to adhere versus having stuff like this, where there's nothing missing here, but technically there was no data right there. So on ours, it would just show up as that white blank. But here, it looks pretty. It's all continuous. And here's another thing. Now, if we come over here and look, so this is just, I'm highlighting areas that you can see the issues, but it's not that an issue. Photogrammetry is great. Love drone deploy. Love, all these platforms. I've used them for years myself. No hate. Just different ways of skinning the cat, kind of say. So here we have these paint stripings, right? And it gets really thin here in the middle and thick here at the top. Now, I was out there in real life. It was not like this. It was full. It was a rectangle. One paint stripe went down this. It's not what it looked like in real life. But actually what's happening here is there's little micro distortions all across the data set everywhere, because what they're doing is it's a agglomeration. It's all the photos stitching together. So this one image is all those photos getting, all their poses and their pixels being blended together to make this one map. And what happens is you just get these little, that error actually is everywhere. Everywhere has all these little errors. It looks beautiful because it's small, but the difference would be what we also did is in ROCK orthomosaics, we're actually using about 90%, if not more, of just the whole photo, the original photo. So this just is the original photo here. And so you see it's a very rectangular paint striping, because this is like 90%. This just is the original photo on the ground. You see what I'm saying? And so you're able to maintain the resolution of the original photo. So that is kind of the ROCK orthomosaics in a nutshell, really prioritizing the original photo to get the most resolution out of it, as well as prioritizing that nadir perspective. So we know the XY locations of objects. So that's what it is. Now, you may be saying, gee, Willikers, that's awesome and all, but it's going to take so long. How many years will it take to generate this orthomosaic? And actually, it's very fast. I think this was a small flight. So I think I flew this in about 5 minutes, I think, from takeoff to landing, a 5-minute flight. And I believe the ortho actually only took 2 minutes to generate. So ROCK desktop, and it's linear too. So there's two really cool things. It's very fast. It generates the ortho very fast on your ROCK desktop. You'll get this. And then the other thing is it's linear. It does not. So if you were to do Pix4D, you did like a 500 photo versus a 1,000 photo versus a 2,000 photo versus a 5,000 photo orthomosaic, the time it takes to process goes up exponentially. It just will go straight through the roof. A 5,000 photo map is just, you're pulling your hair out. It's going to take a long time. We do linear. So doubling the number of photos just doubles the amount of time. Doesn't triple, quadruple exponentially. See what I'm saying? So really, there's no limit as well. And I believe you don't run into any memory issues as well. So it'll just keep appending more photos. And so that's how we're doing it, right? We can just, it's infinite scale kind of thing. So there's not like a memory management issue, because we don't need to hold all the AT points, the aerial triangulation points in memory in order to generate this. And that's why it takes so long in Pix4D and drone deploy, is they're holding all these camera AT points in memory. And that just, it takes a lot of memory the bigger the photos get. An AT point is 2 photos, you get the same object in the same photos. This equals this. That's, your automatic triangulation. So I'm saying this paint striping in this photo is this paint striping in that photo is that, find this corner of paint striping in 10 photos. And that's going to be 1 AT point. And then we're going to do that for millions and millions and millions of points and build this orthomosaic. Anyways, so we scale linearly. It's very fast. It does it. I would say it's safe to say 1-to-1 time, flight time to generation time on a regular laptop. Nothing crazy. I mean, get a good laptop. It's always better. But I have a laptop on the ground. So I use that laptop for everything. But Anyways, it's been big, guys. So this is ROCK Photogrammetry. It's live today. Anyone who upgrades from V1 to V2 will have access to this. We haven't decided how long this free trial is gonna be, and then we're probably gonna just bundle it in with everything else, because ideally what we really want to have happen is we're trying to really unlock all of the information insight inside your data set. There really is no reason. When you fly a LiDAR, typically what people do is they'll fly it and colorize it. But I mean, you got all these photos, and I can say from experience, those photos will just sit on a hard drive somewhere, and then I just never really use them. But you know what? That's a lot of information that's very valuable to your job site, and it's just been difficult to unlock it. Some people will go and take the photos and make an orthomosaic in a different software, and that's been wonderful. But then you still don't do anything with the photos. But how cool would it be if you could? You went out there, you captured that data. Wouldn't you want to use that data easily and access it, in a very simple fashion? So that's really what we're trying to do, is this whole integrated experience. We'll take the pain away from like organizing all these disparate data sets and bring them together. And whenever you use our one platform, you're able to get all of that captured at one time easily. And then you can really unlock it with our platform and our software. And then you can engage with our ROCK Pro services if you want us to do deliverables for you. So planimetrics, CAD, we do Revit models, so BIM, a lot coming on that with the ROCK Inspect, and obviously just surface models, planimetrics, and all of the above. All right, guys. So I think that was about 41 minutes of me just talking to you. I want to do a lot more of these, and I really want to build a community. Like, I think that's really important to me. So much of this industry has been siloed, and we got a lot of opinions out there and a lot of people, but I just would rather work in the public. And when we do something right, I'd love for people to say we did it right, but that's hopeful thinking. But when we do something wrong, I expect people to talk about it as well. I think all of that is what builds a community. It's what builds myself to be better. And I preach this with the company every day, and all the ROCK engineers, employees, and staff, is like, when someone calls you out, it's good. It gives you, without that, you don't have an opportunity to be better. And that's really what we want. We want to be better every day because we believe in this. We believe in these products. We believe in what it can do for land surveying, for construction, for even, archaeology is really cool. I wish there was just a massive amount of money in that, because I would do it every day. But utilities and DOTs and road work and all the above. So yeah, I'm personally very passionate about it, and I think it's just the bee's knees, and we want to do more of it. So we're going to do more of these live streams. Next week, I'm going to go live again, same time, same place. We'll have our support team on Wednesday going live, and I believe they're going to go over photogrammetry, and they have a lot of experience with Pix4D, drone deploy, and propeller. And so they'll be able to answer any questions, as well as kind of walk through a workflow with it. That'll be next Wednesday. I think around the same time we'll get that launched. And then what we're actually going to do is, on our website, rockrobotic.com, we're going to be posting all of this information. So we're just going to have live streams going there kind of all the time. So stay tuned to that space, ask questions, and then we'll answer. We're just going to tear down the walls, break the barriers, and communicate knowledge from our brains to your noggins, and together we can all get better and build a future. Because there's too much to be built. That's all I got to say. There's too much to be built. There's too much happening. And if we don't work together, it just doesn't happen. And that's really what the message here is. We're going to work on the week. We're committed to being the public. We're committed to talking with everyone and just making it happen. All right. With that being said, why don't we jump over to any questions? We got 15 minutes, and shoot them at me, and let's get them. In fact, Patrick is going to queue them up for me, and then I'll just answer them. Cost and turnaround for upgrading our current V1 to V2. Right now, we already got a lot of people that reached out to us since the video launched yesterday. It's going to take about a week. So it technically takes about an afternoon of 2 of our people working to upgrade it. But we're queuing them up. And so we're going to do batches. Every week we'll do a batch. And so first come, first serve. Once your time is here, you'll ship it in and it'll come back to you in about the same week. As long as we get it at the beginning of the week, we'll get it out at the end of the week. We get it midweek, but we're going to try organizing them in batches, so that way we can kind of manage our crew as well. So once you do come up to your time, it'll be about a week where you will not have your unit, and it'll be in transit. It'll go through. We're going to take it actually we're going to do a QC/QA and look at everything just to, while we have it in our hands, we're going to inspect your unit, make sure everything looks good. And then we're going to do the upgrades, and then we're going to do some calibrations, and then a final test data set. And then once we all wrap that up, we'll ship it back to you. And hopefully everything will just be great. I mean, I've never crashed one. I'm just kidding. I have. They crash. People run into things, but whatever. And it's $2,000. And then we're going to offer a discount of around $700 for if you can help us out. We'll help you out if you help us out with the social media thing, the 30-second clip. I would love to help you with it too. Just to communicate. I'm forcing us to build the community, guys. I'm forcing it. So that's why I'm incentivizing you guys to help us build this community. The price of the V2 is the same as the V1. So right now it's at $30K for the hardware. And so no price change. And then we're probably just going to bundle in the photogrammetry with it. But we didn't finalize that. But I think that's where we're going to, with the cost of the software. So like desktop is $2,000 a year. We haven't decided fully yet on that. So yell at me, make your case, plead your case. Do these improvements translate into improved SLAM accuracy? They do. Yes, everything's better. I mean, that's what we've been saying internally, is literally everything gets better. So it definitely does. Yep, SLAM's better, mobile's better, aerial's for sure better. Everything's better. Would the data quality of high-end GNSS be dependent on the quality of the antenna? Always. Antennas are where the signal is captured from. And so if I have a broken inlet here, and I have, oh boy, I have a few antennas sitting around. One of the antennas is actually underneath the computer right now. It's propping it up. So I can't use that one. But yes, so the antenna is very important. So on the drone, we use a helical antenna. And then the mobile mount and the ROCK base, we have one of these large antennas with a huge base plane on it. And so helical antennas help with multipath. They actually do pretty well. But the big base plane on these kind of these more patch antennas, that, really helps with the multipath. Point of story is yes, but we've tested a ton of antennas, and that's the ones that you're getting with the R3 Pro or the mobile mount are top of the line. Like they check out with the best of the best. What about GPS SLAM algorithms when mobile mapping? Oh gosh, Brian, have I been talking? Does everyone know about this? Yes, this is right now. It's going to be, so we're going to do GPS enabled SLAM. Technically, SLAM enabled GPS on mobile, right? They're the exact same thing. Right now, the GPS enabled SLAM is technically in the ROCK desktop. Whenever this V2 comes out next week, we are still doing some QC/QA to make it better, but essentially that's already performing internally. So we're doing it internally. The dev team is probably shooting daggers at me because we got to launch that next week and they got to finish it. But it's not done yet. It's very close. I think it's going to be in there, but hopefully it'll be out in the next. It's going to be in there, but hopefully it'll be like done in the next couple of weeks to a month. That's what I would say. Because it works. And we've actually looked at a lot of other people that have tried doing this implementation. And so like we actually had photogrammetry done 6 months ago, I think. But it just wasn't good enough for my standards. I looked at it and I said, this just isn't it. It's not it, guys. It could be better. And then with the V2, it actually cascaded backwards into that and made it better. The same thing with the GPS enabled SLAM. I've seen other people's GPS enabled SLAM and it's just not, it's not there. Ours though, whenever it's been working, so we've been seeing it, and we expect that same accuracy that you're getting with the aerial, if not better, even in multipath environments. So that's been our kind of gold, our North Star. So it's almost there, but hold with us. Is the V2 a software or hardware upgrade? It's all firmware and software actually. So all timing. So a lot of rewriting of how things are done on computers. So there's an internal computer in the device here, as well as the IMU, and how, like I was saying earlier, most of these IMUs, if you crack them open, they actually use a lot of the gyros and accelerometers. And the big thing that makes every IMU manufacturer different is the algorithm. So we've actually been that's what we've been working on and trying to make all this stuff better. So it's all software, but it needs to be, we have to plug into stuff and upgrade things one by one, and then we ship it. How does the camera work at night? This camera don't work at night. This camera works great at night. So the laser, no problem. It's an active sensor. It makes its own light. Works actually, technically speaking, it would work better at night. The 26 megapixel camera does not work at night. It's got low light performance, but yeah, definitely not in the dark. Does our software work with other cameras? The ROCK desktop is, well, anyone can use it for free, actually. If they just want to visualize data and use it as a visualizer, kind of have that on your desktop, anyone can download it and use it for free. And it works really good for that. You can do measurements and play around with all of the different features of point clouds. And then the actual processing that we do to take the raw data and generate the point cloud, that's all ROCK specific. And then the ROCK cloud, that works with all data. So anyone's LiDAR system, L2, Recipe, Phoenix, Yellow Scan, all these work on the ROCK cloud, and you can do the analysis on there. So the only thing that would be specific would be the generating from raw data to point cloud. So raw data to the SLAM algorithm to point cloud, raw data to the PPK tightly coupled algorithm to point cloud. That would be ROCK specific. Is the desktop perpetual license? It's not. It is a yearly license, and we believe in, it upgrades constantly. So that's kind of why you're paying the yearly license. And what we're trying to instill is that we're committing to you as much as you're committing to us with that perpetual, or the software license, that we're committing to keep improving things. So V2, we're trying to not make you buy a new one right now and improve it. Same thing with when we do new pushes to desktop, photogrammetry, and all these other things. Like, we want to just keep providing. We want to prove to you our value. That's really what it comes down to. So if we can prove to you our value, we believe that we're worth it. Change the color calibration process in ROCK Cloud. It's in ROCK Desktop, and it is the same process, but it's significantly easier to do. Because if I can share my screen again here, Patrick. And let me go back to this intensity gradient, is what I like, and show you a paint striping and show you what I see when I look at this. Okay, so we got a paint striping right here, and we see blue. We can see some green here, and then red, then green, then blue. So this is like the telltale sign. I can just zoom in, or what do I do? I'm looking at what you guys are seeing, trying to see if it's easy to see. Okay, so we got red, green, blue. So actually what's happening here is that those green dots is whenever the laser beam is half on the paint striping and half on the black surface here. So what I'm highlighting here is how accurate the actual edges of things are. So now when you do the calibration of the camera and ROCK Desktop, you can really easily see the edges of things. So it actually makes it very easy to just say, oh, because you can say that's the edge of the paint, and then you'll also be presented with a photo, and you can see here's the edge of the paint of the photo, and then I can say here is that same edge right here in the LiDAR data. So before, with the V1, you didn't see this telltale sign here of this green, red, blue, and so it made it just a little bit harder to get that calibration done. But now, since it's so accurate, it's actually pretty simple. I found it much easier. I just did it once and it just worked. So that's that. What is the best drone for the ROCK system? All right, don't get me started. If anyone follows me on LinkedIn, don't get me started. You can stop sharing the screen there, Patrick. My opinion's the DJI M350. Thing's awesome, man. I fly it all the time. It's so good. It's just a great drone. It's really, really good. I've flown all the other drones. It's still the best one. And there's a lot of political opinions out there. I just personally, I'm trying to make 3D maps and do, civil engineering, construction. So like that's the world and the lane that I'm in. So I'm just trying to get the best tool for the job. And so for me, the DJI M350 it just is the best. And I'm saying it like this because I get a lot of flack about American-made drones. And don't get me wrong, I want everyone to succeed. I love the innovations happening, but a spade's a spade, and M350 is the best. No matter what anyone has said to the contrary. Like it's definitively the best. Like I love doing comparisons. Actually, on YouTube, I'm the first person ever to do a comparison of different LiDAR systems. It's crazy. And everyone told me that all these other manufacturers, because I knew them all, they were like, oh, you can't do that. You can't do that. I got yelled at. I made enemies, and people just didn't like it. And but to me, I believe like that's what you got to do, guys. We got to look just what's going on here, and apples to apples. Just show me, and then I can make an educated decision as a consumer. Has there been any integration with Whisper Drones? As many clients are moving away from DJI. Thank you. I love Patrick. You're queuing this one up. Logan. So this is our universal mount. And so essentially this has 4 screws on it, connects to the top of the LiDAR right here. So let me show you. So we got the R3 Pro right here, and this will just connect right on top, and that converts it over into boom. And so now you can take this, go to the smart dovetail. You can go to the toad in the hole. There's a bunch, like this is the same hole pattern as all the smart dovetails, as well as the toad in the hole. And so we sell this, and then you can buy the adapter that connects on to the Whisper or any other drone. Everyone kind of uses the same Grimsey mounts or the toad in the hole or the smart dovetail. So with this one piece here, you get the GPS and power. We give you guys XT60 connector, so you can get power from the drone, and then we'll sell you a GPS that clips on to the arm that connects into this. So that's the universal mount right there. And then I think I actually have a smart dovetail on my desk somewhere. No, I do not. It's in my closet. But that makes it's really easy. So, yep, that's how you'd connect it to any drone, really. So we connect FreeFly Astro, Whisper, any of them really. It's basically, can they carry the 1.2 kilograms? So this is pretty light, 1.2 with the camera, and anything can carry it, works. Has Rock Pilot app moved out? I think it is out of beta. I use it every day. I'll get a ruling on the field from the support team, but I use it. I think they've been using it too. So Alex will answer in the comments. How much does the ortho increase processing time? It's about the same. So it adds a couple minutes. It's really fast. Like I said earlier, it's about 1-to-1 to flight time. So a couple minutes, because that was only a 5-minute flight, but about 1-to-1 with flight time. And the requirements of overlap aren't as stringent. So you can do less side overlap, so you can cover more area faster. Oh, thanks, Fred. Thanks, Fred. Appreciate it. Yes, photogrammetry is only available on the upgraded V2. So technically it works on the V1, but without the enhanced accuracy, it suffers from these small defects, and I don't think it's not fair to our customers for us to release a product that doesn't adhere to what trust me, the dev team and the rest of the ROCK team, they get it all the time from me. I'm a very stickler for the details, and I push it to the limit, but I'm glad that everyone puts up with me. I'm glad that you guys put up with me, and because I want it to be the best, What is the camera capsule interval required for the new Orthomosaic software? So it's just a timed interval. It does 2 seconds interval, and that's fine. Almost is. I haven't pushed it yet to see how fast I can fly to just do orthomosaics. That's a good question. Good video. I'm thinking like I should do the same flight and just go 5 meters per second, 10, 15, 20, and just see like, does the orthomosaic, what happens to ortho? So I think it'll be fine though for almost anything. It's going to be included in the subscription. We have to figure out exactly how the fine details work, but that's essentially what's going to end up happening. We're basically including it in beta for free for all the V2s for, I think we're going to do 3 or 6 months. So we're kind of kicking the can down the road to figure out exactly what we're going to do. And we want to get feedback, from everyone first, just to make sure it is everything that you guys need it to be. Will many of these features be retroactive on existing data sets we have in the ROCK Cloud account? Actually, I think all of the, if you uploaded photos previously, you should start seeing all those photospheres, all the little blue circles. I believe that all that should show up. And I think all of the, if you have an orthomosaic and a LiDAR data set, all the like the measurements are retroactive. So if you did do measurements, or maybe if you had measurements, I think you might have to resave the project and then they'll show up, or just like make a small edit to one and then resave. I believe planometrics already shows up. So whenever we do planometrics with ROCK, so CAD files show up on orthos and the point cloud. Side note though, that's actually something really cool about doing the ROCK orthos. Sorry, I'm like shaking the whole desk here. Is we see this a lot. So customers order from us the planometrics and they will use another service to do the ortho. They have a ROCK or a different LiDAR to get the LiDAR data, and then they won't match up. And it's like, who do you point? Who's wrong? And oftentimes it's the ortho was slightly off, you know? So with this though, they're like canonically the same. So everything lines up. This isn't a question, that's a statement. ROCK Universal Mount. Can you speak more about CAD file deliverables for customers? Absolutely. So so you can order planometrics, that's one item, but actually we do generic GIS as well. So some people just say, hey, can you find all the fire hydrants or all the poles? And I just need a file, a CSV of all that, or XLS spreadsheet. But the ROCK planometrics, right now, we have a base set of features that if you go on the ROCK Cloud, you can see kind of our features list that we will do all the CAD for. You can ask for custom symbols. So we do the custom symbology. And then we will also, there's a lot, we can do feedback too. Like if you see something and you want it a little bit different, maybe that's not how you code your features, your feature codes, and you want them coded a little different, no problem. So all of that is, we do all that here at ROCK with our pro services team. We have a great team of experts on pro services that work tirelessly. And I think, Mike, actually, you had a lot of great experiences with them. I remember I saw a data set, I don't know, probably there's a lot of overhang and you're doing some cliff faces, and you know, contours technically don't go in and back out. So if you have a cliff and then it tucks back in, like a contour should never overlap itself. So we had to figure out some pretty cool deliverables for you. Hope that was all worked great. What about GIS integration and data interoperability? Yeah, so you can export everything as a DXF, DWG, or a shapefile, I believe. And so that should be all fine. And then we don't support all uploads right now. We're working on it into our platform. We can export everything in the file formats you need. We even do like land XML for like civil 3D. And then we are working on doing more interoperability with importing. What to expect next from ROCK Robotic? To take over the world? No. So next week is Colorize Slam coming out, and then the ROCK Inspect tool. So the colorization and making the photospheres usable from the 360 camera included on the V2 of the Slam dock, and then mobile mounting, and then a unified algorithm for everything. That's kind of where it's at for one thing. So on the production of data, GPS, no GPS, Slam, you know, PPK tightly coupled, just one unified algorithm that will take you inside, outside, in a cave, out of cave, just one process. And actually right now, there's the underpinnings of that inside of ROCK Desktop, and we're going to launch that or talk about it. It's been live for a while, but we have a workflow where you can tag GCPs in SLAM data and reprocess the trajectory to get all of your data very accurate in Rock Desktop. And so this is different than everyone else. So every other software that people that do SLAM products require you to get the GCP in the time of capture when you're out there in the field. Like you take the device and you set it on the ground, and there's, you got to capture the GCPs. But what we did is we inverted that. We said, we want you to tag them in post. That way you can always get more GCPs and, keep adding to your data set if you ever wanted to do anything. So we made that workflow, works great. And that's a very similar thing as you can think of the GPS signal as a GCP. So that's basically what we're doing, and making a unified workflow for all of that. So you as a user can just capture, not have to worry about all this stuff. That, and then I'm going to say one other thing is the unification of all this technology and how do you communicate and work with it. This is really big and top of mind for us. How can you talk to your data and just find all the fire hydrants? There's more to that statement. So unpack that statement and you can kind of get an idea of what we're thinking. All right. I think, Jason, thank you for that. And I believe that's also a passive term to tell me to wrap it up and in the webinar. So guys, thank you for watching the webinar. We're going to be live again next week on Wednesday, same time, same place. We will put links on LinkedIn, Facebook, YouTube. We'll be live again on Thursday. I'll be live on Thursday. And then the following week, I think we'll probably have 3 webinars. And we're just going to keep this velocity going and get our messages out to you guys to get all your questions answered. Hope that sheds some laser light on all of your thoughts for the ROCK R3 Pro V2. And with that, I'll see you on the next one. Ciao.
Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it. Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it. Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it. Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it. Ready to dive into the future of mapping? We've got a whole series of live webinars planned on rockrobotic.com where we'll deep dive into our products and services, showing you exactly how they're going to radically change your mapping projects. Don't miss it.